Happy Thursday, I guess.
I was about to say happy Monday, but here we are.
Yeah,
Thursday.
no, yeah. Anyway, it's not Monday, surprisingly enough. Yeah, so for the audience out there, we did postpone the show until today because last Monday we weren't sure if there was going to be a I don't know.
Chaos. There was
Yeah,
chaos.
yeah. It
Yeah.
was so for Silicon Valley Bank was imploding. It wasn't clear whether or not there was going to be any resolution to it, and we figured that if things had went south, which they very well could have, our listeners probably had bigger problems in their hand than wanting to listen to us ramble on a Monday morning. So anyway, welcome to Thursday, Felix. Good to see you. Yeah, for
Hi.
people who don't know who you are, do you want to give a quick intro?
Yeah. I'm Felix. I've been doing data infrastructure for nearly a dozen years now, the last 3 quarters of which at LinkedIn. So I guess I'm a dinosaur of the company by now. And I've been focusing on the Venice project, which is a derived data store that we've open sourced last September. It's used by a bunch of AI applications at LinkedIn. I'm happy to talk about it and other data infra systems we have, challenges of, running multi-region data infra and stuff like that. Wherever it takes us, looking forward to it.
So when did you get started with the Venice project? I was looking at the GitHub page, and it looks like it started in about 2015 or so.
Yeah. So the ideation started the first year that I joined LinkedIn in 2014. At the time, I joined the Voldemort team, and we were interested essentially in doing. So Voldemort had a bunch of different facets to it, but one part of it that was especially interesting to us was how you could very quickly and easily reload data from Hadoop, right? So you could swap your entire data set of things that you've computed in Hadoop overnight. And we thought that made our internal users very productive in pushing out like AI applications and stuff like that. And we wanted to do a similar thing for streams, right? Because stream processing was coming up at the time. We thought it was going to be big. So essentially the original idea for Venice was let's do for stream processing what Voldemort did for batch processing, right? Which is to unlock the data, make it available to online application for querying, right? So that was kind of the idea. Then the project was approved not too long after that, but it started off pretty slowly, right? So we had a bunch of other competing priorities for a while, and we basically got started in earnest, I would say, at the beginning of 2016. That's when we finally managed to put together a fully staffed team, started working on it. And at that point, Voldemort was a bit more in maintenance mode, pretty stable. So it wasn't taking up a whole lot of our attention. And we hit prod at the end of 2016. So about a year of full team development. And then we fully decommissioned Voldemort in 2018. So that's sort of the timeline of the origin of Venice. And then we've been going at it full steam ever since.
That's cool. And this is streaming live on LinkedIn. So, I mean, how does this impact, basically the user of LinkedIn? Like, what's the end goal of all this?
Yeah. Well, thankfully, as far as I know, if this live stream goes down, I'm pretty sure Venice is not to blame. But I could be wrong. It's used in a bunch of places. So one of the prominent use case for Venice on LinkedIn is the feed, right? So you see a bunch of posts in some order, in some selection, right? When you load the main page. And obviously there's like way more posts than those that we showed you, right? That we could have showed you that are coming from your network. So the scoring of the relevancy of each post is based on essentially querying a bunch of ML features out of many different Venice tables, and then passing that into an ML model that is used for inference, right? And so that's one of the very high throughput use cases of Venice. And then once we have a score for each of those potential posts that we might show you, then we rank that and show you just the top K most relevant ones, right? So this, by the way, includes many things, not just Venice, right? There's a whole ecosystem to make the feed work, but Venice is one big part of it. Another kind of recommender type system is people you may know, right? So if you go in your network page and you see these are the people you might know, well, this is sort of a similar idea. Well, first we query the graph database, which is another system to get a fraction of your second degree connections. And again, that's way too big for us to recommend all of it, right? So then we whittle it down with a kind of a rough filtering at first to 5,000 candidates or so. And for each of those 5,000, we query Venice and retrieve a bunch of ML features. We also push down some compute into the Venice servers and retrieve the result of that. And then all of that gets fed again into a ML model used for inference to score each of the potential candidates. And we return the top K most relevant ones. So this is sort of the pattern for recommendation, right? There's a bunch of recommender systems everywhere throughout the site. Some of them are kind of very visible, like the ones I showed, but there's also a bunch of very kind of implicit ones. Like, let's say you type the name of somebody on the messaging page, how are they ranked? Well, that's also a recommender system. Like it's everywhere, basically, right?
So tell us about, so behind the scenes, you have Venice. Venice is this storage and query engine. It can handle streams. It can handle asynchronous data. Where are these features coming from? Like what kinds of systems are running behind the scenes? Because it sounds like you're computing features in a very real-time way, which is the big motivation for the system, the big improvement beyond Voldemort.
Yeah, so Venice supports both batch and stream, and you can also combine them, right? So we've been calling that Lambda architecture for a while, right? Or some people call it kind of Kappa architecture, where both the stream and batch part are both implemented as a stream processor. So Venice supports all of these patterns. And I would say batch is still a pretty big part of how Venice is used. And there's also a growing fraction, which is streaming inputs. So we've got all of these, right? So the batch stuff is happening in Hadoop. We're pretty old school, right? We still use Hadoop. Maybe we're the last people that still use Hadoop. I don't know. Probably one of the biggest Hadoop deployments on the planet at this point. But essentially, it's the same concept as S3 plus EMR or whatever you're doing there, right? So so we run Spark like everyone else. We run Trino, all these things, and you can crunch your data there. You can train your data with TensorFlow or other things, and the output of those ML training jobs are what gets fed into Venice. There's also some non-ML workloads that put data into Venice, but it's primarily ML. Does that make sense? I'm not sure I answered.
Yeah, no, it definitely does.
Sort of.
And I think in general, we're both very interested in this idea of making ML more real-time, more scalable, more responsive to what's happening in a user session. I think we've seen a lot of improvements in that domain in the last decade or so, and this sounds like it fits right into that notion.
Well, it sounds like it's kind of spearheaded a lot of that too.
Yeah.
So that's pretty interesting. Yeah. Walk me through this. So, I mean, it's. I mean, you're operating at a very large scale. How much of this stuff was you and your team having to just think about the problem, come up with a solution? I mean, because it didn't seem like a lot of this was, off the shelf or available as open source packages. So, I mean, walk us through that kind of discovery process, or just thinking through these problems.
Yeah. So even before we open sourced Venice itself is also built on a bunch of open source components, right? So I often say we stand on the shoulders of giants, right? So we use Hadoop, Kafka. We also use Apache Helix for our cluster management. We use RocksDB quite heavily. Great software for the storage part. And we use Netty and other things, like a bunch of open source. The nuance is how they're plugged in together, right? So in terms of have we had to sort of invent things? I mean, I think there are some parts of Venice that are maybe a bit novel, like the way, for example, that we handle the orchestration of a use case that has both batch and stream inputs, for example, right? We've built it in Venice, and then we've seen a bunch of other derived data systems inside LinkedIn kind of copy the pattern we had done. So we thought it probably means it's a useful pattern. So the way we do it basically is our data sets are versioned, right? And then when you do a batch push, it dynamically creates a new version of the data set and loads all the data in there. And that's all happening in the background. So you have your current version that is unaffected by this, still serving live traffic. And then in the background, we create this so-called future version, right? And data gets batch loaded in there. And then when it's ready, we have all of the real-time writes that have been coming in queued up in a buffer, right? We use Kafka for that. And then we replay the last little bit of those real-time updates on top of the future version, which is still not live, right? And when we're caught up on that replay of the recent write events that came in, then we swap the traffic. All of that is orchestrated automatically, right, by Venice. So that's a part that I think is a bit a novel, maybe. And we have a few hundred use cases that are using that internally at LinkedIn.
Talk about this notion. So in the title of the stream, we talked about multi-planetary software. And I think coming back to that theme, tell us more about that. I mean, I think one thing I'm aware of is that systems like Kafka and Hadoop can't really do this. In other words, they're distributed cluster systems, but you need to have the cluster in one place, generally able to communicate, or you're going to have a lot of problems. Then you have newer projects like Pulsar that are designed to be like multi-cluster, where you can have a cluster maybe in Wisconsin and then another cluster in Venezuela or something, and they can still play together, even though you're going to have problems with consistency and latency and other things. So tell us more about that.
Yeah, definitely. So at LinkedIn, we run 3 data centers at the moment. And like you said, these off-the-shelf systems like Hadoop, Kafka, they're really not intended to span across regions, right? And so the way we run them is, we have Hadoop grids in different data centers that are kind of independent of each other. We have Kafka clusters in each data center that are independent of each other, and so on, right? Now, we have sort of a arm's length coupling between them, right? Like we have certain systems that replicate data back and forth between the grids, between the Kafka clusters. And so the data that lands in one region is not instantly available in the other regions, right? It has kind of a replication delay. And so we've kind of built Venice with that assumption in mind, right? That we had to make the whole system appear as one, but that in reality, internally, it's built of these kind of fractured locations, right? That are kind of disjoint, separate from each other. And so within Venice, as an example, each region has a Kafka cluster that's dedicated to Venice. And the Kafka cluster is sort of managed by the Venice system, right? The Venice creates, deletes topics in there, does the replication between sites. And the thing that's kind of interesting there, I think, is if you have, let's say, stream processing jobs that are present in multiple regions, and they're all processing the same data for redundancy, right? So then you can have race conditions, right, between these regions. So you have data that is sort of conceptually the same, but comes at physically at different times, and you have keep things simple. Let's say we think of just 2 data centers, right? Then you have two-way replication, right? It goes both ways, and so that means the Venice deployment in each of those locations needs to cope with the fact that data comes out of order inherently, right? Because you're more likely to see the local data more quickly, although that's not always the case. Sometimes maybe the local Kafka is acting up and it's the remote data that comes first. But the general case is the local data comes faster. And so that means you could have events A and B that come up as B and A on the other side, right? And so we need to deterministically resolve those conflicts, right? And that's where I think it's been useful to look at the literature of CRDTs, conflict-free replicated data types. And so we adopt some of these concepts inside Venice, and in other systems too, for that matter. And that's sort of how we've been dealing with these issues. And in terms of multi-planetary, the idea essentially is if the system is designed to support this out of order arrival and still come up to a coherent result in the end, then I think that is an architecture that could scale to even longer delays between regions, right? Mm-hmm. Which would be the case if, let's say, we have a base on the moon, then the ping is going to be like 1 or 2 seconds, right? If you have a base on Mars, then the ping is going to be anywhere between 4 minutes and 20 minutes, depending on the configuration of the planet. And for 2 weeks out of the year, you'll have a solar occlusion, right? That sort of blocks communication. So maybe you have a 2 week ping at that point if you don't have a proxy satellite to go around, right? So you kind of have to make those delays sort of an intrinsic part of the design, I think, to make that work.
So to be clear, is Elon Musk working with you on a Mars
Mars
system?
Okay.
Nope.
Okay.
But it'd be Elon, you should reach out after this if you're watching. Check in with Felix about a Mars data center.
Yeah, I don't know if it's a pleasant experience to work for Elon. I'm happy to sit on the sidelines and be very impressed by all of the innovation happening.
But you get to go to Mars, so I'm just kidding.
But
yeah, that's interesting. It's an intriguing idea, though.
Yeah.
I think, right? I mean, I can't remember what projects I was listening to that were talking about kind of the interplanetary internet or something like that, right? It's a very interesting concept. So, what gave you the idea for this? Yeah, what gave you the idea for this? I mean, because it's like you're working on a system, for LinkedIn, then it's like, well, this could obviously extend to, space as well. So,
I mean, I don't know. I've always been interested in space. I guess by now I'm sort of getting too old to become an astronaut. So I'm sort of vicariously living the dream by thinking, maybe we'll just build the infrastructure for it instead of,
So you're not at space camp right now, just to be clear. Like, okay.
Nope. This is not Roscosmos.
Okay.
But so I mean, I guess you could say like my professional thesis in a sense is I'm pretty bearish on the photon teleporter working, right? So I think I think the speed of light will remain a hard constraint for maybe forever, or at least for quite a while, right? Until we discover new physics that allow us to break the speed of light and make that sort of production grade. I think, that'll take quite a while, singularity or not. So the point is, I think right now, because the Earth is pretty small, we're kind of allowed to cheat a little bit in our system design, right? So, you know, you can do a cross-region call if you really have to, right? Maybe it'll cost you 100 milliseconds, 200 milliseconds. It's not great, but you can live with it if you don't do too many of those sequentially. It just won't work at all if we're anywhere farther than the distances we can have on Earth. So when I look at systems like, let's say, Google Spanner, that makes the whole planet strongly consistent, well, that's pretty interesting from an academic standpoint, but I feel like it has limited long-term applicability, right? And that's not a popular opinion, I think, because everybody loves strong consistency. But yeah, I just think like if you fast forward a few decades in the future, assuming we haven't gone extinct by then and progress has continued, I think it's likely that we will have bases on the moon and elsewhere. And at that point, I think it will become pretty clear to our industry that strong consistency has been a crutch that we've used for decades, and that any software that needs to run in a multi-planetary fashion, it just can't rely on that. It has to be sort of built for asynchrony, in my opinion.
Before the show, you talked about having a separate data center in Asia, which is a pretty big distance for planet Earth, right? So going from the United States to Asia, like Trans-Pacific. Tell us about some of the challenges you encountered there. Like what kinds of headaches did that cause you and how did you attack those problems?
Yeah, right. So at the time we were building this Singapore data center that we've had for several years. At the time, actually, we did have a planet-wide strong consistency system. So there was a way to run Voldemort in a certain configuration where it would actually wait for an acknowledgement from all the data centers before returning back control to the application, right? And that was somewhat slow, and most people opted out of that mode, or rather didn't even opt into that mode to begin with. But some people did, and that was sort of at the time that we had data centers just in the U.S., where the ping is maybe between 15 and 40 milliseconds, somewhere like that, right? In that range. Then when we went to Singapore, we suddenly had a ping of maybe 200 millis, and then those kind of operations break down, right? Like especially like consumer-facing web applications. I mean, no disrespect to my end users, but these people are impatient, right? So you can't just have a page load takes many hundreds of milliseconds. It's sort of or second plus. It just doesn't work. So we actually stopped using that flavor of Voldemort as part of that migration. It was a pretty big data infra migration project. We migrated all of those so-called Voldemort read-write use cases, which was kind of the strong consistency flavor of Voldemort. Migrated those into our document store called Espresso. Espresso is built with the notion that you have strong consistency only within the local zone, and any data that's happening that's getting written in other zones is replicated asynchronously, and then there's some last writer wins, right? So we kind of forced that as part of the expansion to the Asia data center, and that was pretty challenging. Like these types of inter-database migration, of course, it's all happening live. Can't take the site down. So that was pretty interesting. And then when we were done with that, we were left with basically just the Voldemort read-only part, which was the one that ingests data from Hadoop which eventually became Venice. So that was kind of the history of that effort.
So back to the consistency argument here. I mean, you will ruffle some feathers saying that strong consistency is sort of maybe out of vogue.
A crutch.
A crutch, yeah, that's what he said. And what led you to this realization? Because I think it's been hammered into database people that strong consistency is sort of the default way to go. When did you have the realization that's maybe not the case?
Yeah, so to be clear, like I made a provocative statement there, but I do think strong consistency is important in some cases, right? So from a user experience standpoint, let's say you're editing some content, let's say like the user is updating their account details, whatever system you're running, right? If the user submits that and it appears to succeed and they reload the page and the data is not there, they're going to think like the thing is pretty wonky, right? So you got to have strong consistency to ensure that this doesn't happen, right? And you can't just like cache what they did on their browser side, right? Because what if they whip up their phone and look there, right? It's got to be there too. So you got to have strong consistency, at least in a local context, like local geography, local zone.
Or if you're like at a bank and like,
you refresh the page, your money's not there.
Yeah, that actually happened to Wells Fargo customers last week, surprisingly enough.
It did.
Yeah,
yes.
Don't joke.
Well, the banks still run on COBOL, from what I told, so it must be difficult to maintain. I don't know.
Yeah.
So strong consistency has its place, certainly, but I should clarify, like, what I think is the real crutch actually is a specific kind of design pattern, which I call read, modify, write. Okay, so that's essentially when let's say in sort of SQL terms, right? You open a transaction, you select some data out of the database, you modify it inside your application. So you're running some arbitrary code to look at what's already there and then modify, let's say, some of the columns of that row, and then you write the whole row back. Okay, so you update, and then you commit your transaction, right? And maybe you do many of these as part of the same transaction, right? That doesn't really matter. The example still works with just a single row. Now, what you're expecting, because your database gives you ACID properties, right, is that this will either fail or succeed atomically, and you will not have kind of a half-written row or any sort of weird stuff like that. So essentially, you should have kind of a clean failure, right? If it so happens that maybe another instance of the application came in and did the exact same thing as you, but won the race, won the race condition, then by the time you commit, the state in the database is sort of stale from the point of view of your transaction, and then your transaction should fail. And then at that point, what you need to do, if you care about that transaction succeeding, is retry the whole thing, right? Maybe with some backup if you're nice. So that whole pattern, I think, is broken, and we've seen that in many cases. Like, for example, I'm maintaining some kind of counter, right? And I'm reading the row, I'm doing +1, and then writing it back. You can make it work correctly, but it's just not very performant. It's not fast. It's not scalable. If you have concurrent writers. If you don't have concurrent writers, everything's fine, right? But if you have concurrent writers, then that means, let's say you have 10 writers, then only one of them is going to succeed, 9 others will retry. Then one of those will succeed, 8 others will retry. It's pretty terrible, right? You have sort of a, I don't know, n factorial, I suppose, number of attempts to complete n operations. So it definitely doesn't scale if you have many concurrent writers. Now, the problem is, the window of that race condition is pretty small if you're talking about computers in the same room, right? Just talking over a LAN. But if you're talking over the WAN across regions, and you have a ping of hundreds of milliseconds, then that window widens, right? So it exacerbates the problem. And so I think it's way more powerful if we can show some constraint and say, I'm going to use some sort of declarative facility provided to me by the database where I push down my mutation into it and let the DB deal with it, right? So if instead of saying, I'm going to read, I'm going to do this +1 in my shitty like Java code or Python or Ruby code and write back, instead just tell the DB, do me a +1, right? And then if you let the DB do it on your behalf, it can serialize all of these operations, which don't really have any ordering implicit to them, and just crank them all out very quickly because the database can afford to do these sort of read, modify, writes very quickly at the local level, like within the same box. So that's sort of the idea. Now, of course, it doesn't work cleanly for everything, right? Now I gave it kind of a trivial use case of the +1, but I think having sort of consulted with internal users for many years trying to build their applications on top of our infra, I think a very, very large fraction of the use cases are actually trivial. Like, I want to update one column of this row or one field of this document. I want to do a +1. I want to add one item into this collection. These are things that we can do declaratively. Like, we have the know-how to do that. And then if we do that, then we sort of remove the constraint that we must all be in the same region for this thing to have a chance of working. It also happens to work if the concurrent writers are many light milliseconds, light seconds, light minutes apart. If that makes sense.
Yeah, it definitely does. And it reminds me of the idea of like an event-based architecture versus a state-based architecture, where instead of thinking about saving like pieces of state to a database, you just send events, they go into a stream, and you send them on their merry way. And different events will arrive from different sources. And then once they get consolidated and processed, then the processor has to decide what to do with conflicts and such. Like, you've got to have a conflict resolution algorithm. It's part of the system.
Exactly.
Yeah. Before we went live, we were talking about derived data systems. It's an intriguing concept. What did you mean by that?
Yeah, so the way I've come to look at the landscape of data systems, which is getting more complicated every year, right? There's more and more options. So I think it's useful if we can bucketize those systems into different categories. And one dimension that I think is interesting is to split systems into whether they are capable of being primary data systems or whether they're more specialized towards being a derived data system. And what I mean by that is, so a primary data system is where you want to store your source of truth, right? You may call it a system of record. It could be your relational DB. It could be some kind of NoSQL offering, like a key value store or document store. It could be some cloud thing, like DynamoDB, Cosmos DB. Doesn't matter. But the point is, for these primary data systems, I think you often care about strong consistency. You also care a lot about your data being durable, replicated, backed up, and essentially you expect that when a write is acknowledged, you'll be able to go back there and find it, right, immediately. For derived data systems, oftentimes we don't have the strong consistency because there are many use cases where it just doesn't matter, right? And those derived data use cases where it doesn't matter, I think there's a variety of them, but it includes like real-time analytics, like the kind of stuff you would do with Pinot or Druid or ClickHouse. The stuff we do in Venice is like ML feature storage. Well, the ML features are not getting written like by the end user. Like no one is saying like, hey, write, this floating point value in my account details, right? This is all inferred kind of asynchronously anyway. So, who cares that it lands in the database with strong consistency or not, right? It'll land there when it lands there, along with the other terabyte of features that it comes with. And there are other use cases like search indices, for example, I think make a great fit for derived data because again, let's say you update your profile page on some social media site. Typically, you're not the one searching for yourself, right? So you'll never notice that the search index is not up to date with the thing you just modified. It's other people looking for you, and they don't know when is it that you updated your profile. Right. So if the search index is stale by a few seconds, who cares, right? Or a minute. So all of these are use cases where it's actually more important to have first-class support for ingesting streams, first-class support for ingesting batch data, than it is to be able to do a strong consistency transaction type of operation. And in exchange for this sort of constraint on the consistency of the writes, in exchange for that, you gain more advanced capabilities in terms of how you can read the data, right? So if you're talking about the analytics system, you're doing some slice and dice on it in a way that is kind of more efficient and performant than you would be able to do in your Postgres or MySQL, right? If we're talking about the feature store, then maybe there's some push down of vector math happening in there. If it's a search index, well, you could do full text search on MySQL if you wanted to, but it's probably gonna work more efficiently with some sort of inverted index structure or a trie or something like that. And then there's a whole kind of relevancy and ranking of the search results, which you don't really have facilities for doing that very effectively in a kind of in most of the primary data systems that are available, right? But you can have specialized capabilities for doing that in a system that is designed to be a search index. So it's sort of this kind of trade-off, right? That I think emerges when you look at whether a system is specialized for derived data or whether it's primary data. And primary data, you can think of it as maybe a general purpose, right? You could store your derived data in a primary data system. It still works, but it's just not going to be maybe as performant for some of the use cases you may want to use it for, right?
I had a question for you. So you mentioned sort of behavioral patterns of users and sort of expected, a good enough behavior maybe, right? So derived might be good enough. Doesn't need to be to the millisecond, but it's close enough. How do you make that determination? Do you work with a product manager, or like how do you translate like user requirements to knowing how to approach these types of problems with your systems?
So I think like I've seen cases. So just to be clear, I haven't done these experiments myself, but I have worked with teams that have done things along those lines where, let's say they would try injecting some artificial latency into a system and measuring the impact, right?
Ooh.
So either latency latency of the online serving, like, will the user be too impatient for this? Or also, in some cases, injecting latency into the write path, like the event comes in later to update the data structure or something like that. And depending how the experiment is set up, like you can sort of A/B test it, right? And then measure, are my engagement metrics impacted by this extra latency, either in reading or writing the data? And so the injecting latency is sort of good for the case where you already have the solution that is fast, but you want to measure the impact of making it slower, which you might need to do if, let's say, you're planning to do a product where to change the product so that you do more work in that path, right? Like, let's say you want to double the size of the ML model that's going to be in that path, then maybe that means it runs a little bit slower. Will the user be too kind of impatient for that? So that's one way to do it when you already happen to have sort of a fast or fast-ish system. The other way is harder to test, right? Like if your system is slow and you want to measure the impact of how good would it be if it was faster, there's sort of no shortcut there, I think. Like, well, maybe in some cases there's a shortcut, like, but basically, like, you're going to have to kind of build the faster thing if you want to measure how well the user react to that, right? In terms of, like, you may be able to take a shortcut in, let's say, building a very small scale version of it, and maybe that allows you to kind of cut corners a little bit and try it out on, like, 1% or 0.1% of users and do an A/B test on that and measure impact. And then that sort of gives you the go, no go for, do I build a full scale version of this? So yeah, some of these things are getting measured. I don't think we do it like super often because it's it's kind of expensive to run these experiments. We do run a bunch of experiments all the time, but this particular flavor of, like, in trying out what if things were slower or faster is a bit more complex. So we'll do it every once in a while only. But yeah, it's the need for speed is definitely there, right? Like, we see cases like where, let's say, we build a new way to access the system that is faster, and then an application onboards to that, kind of upgrades to that, and then they run that for a few months, and then let's say there's some kind of latent issue that we discover with the faster path, and then the user has the option of, like, waiting for us to fix that while staying on the fast path, or kind of rolling back to the slower path, and they're like, I'm kind of afraid of the impact of rolling back to the slower path now. I'll just deal with the minor glitch of the fast path, but please fix it fast, So yeah, the need for speed is definitely there, I think, in many cases. It's kind of ratchet. It's like a ratchet. You can sort of crank the speed up, but then people don't want to let go and go back to slower after that.
And I mean, from a product perspective, you're talking incremental improvements in user experience, but like across millions of users, these do start to make a difference. There's various stats I like in terms of page load time and how it impacts user experience. And so you can imagine similar things with, like, ML inference models. If you can evaluate a second faster, maybe it will impact, 100,000 users a day or something like this. No, that's interesting.
Yeah.
So here's another question. So you've been working on Venice for a while. Are there any, like, big projects on Venice, like big changes that you're excited about that are going to change the architecture in some way or deliver new features?
Yeah, so one of the things that we've been working on is decoupling the pub/sub system. So right now we're tightly coupled to Kafka, but we have some people in the community interested in plugging in Pulsar, and so that is coming along. I think we'll probably be able to plug in a different PubSub implementation, I don't know, a few months from now, maybe. Besides that, a lot of our time, honestly, is spent on like just fine tuning reliability and performance. That's like a huge time sink for us. Like at our scale, thousands of use cases, we see all the weird combinations, right? And things that work kind of on their own don't work when they're combined, and there's like all of these little things that we're constantly polishing. So a lot goes into just general maintenance all the time, and just making the system incrementally faster, more efficient. And in terms of the replication and conflict resolution, the stuff we were talking about earlier, we're actually in the process of upgrading that at a functional level also. So we have so currently we support the conflict resolution for out of order events on only a subset of our operations, right? So you can kind of mutate a whole row or delete a whole row, and whichever of these comes first, then it doesn't matter. In the end, it will be coherent, right? But we also support other operations that are kind of not part of that conflict resolution framework yet. So for example, we support collection merging, where you can have like a set or a map inside your schema, right? And you can add items or remove items from these collections, right? And this is done in a way that does not require a read, modify, write, like I was saying about earlier, right? So you can have multiple applications concurrently, all adding elements into the same set, and it all just works. However, if you have that happening in multiple regions at the same time, currently the way we make it work is we do the frequent flyer mile design, where we kind of send all the data to one data center that gets serialized there, and then everybody sees that order. But we are working on something to make that kind of operation also what we call active-active. Meaning that instead of the frequent flyer mile pattern that we're intently moving away from, you can now have the data be applied immediately on near immediately in local regions, and then it gets asynchronously replicated, and even if it gets out of order, it will still come back to the same result in the end. And for that, we're using sort of variants of CRDTs to achieve that. So I think that will also land in the next few months. Those are some of the things we're working on. There's a laundry list of things, but those are just some of them.
For companies that are interested in Venice, I mean, what type of company do you recommend, or organization do you recommend uses Venice? This obviously isn't something that a two-person startup would probably be using out of the gate, but
I hope not. Like unless
they're doing some cool stuff, right? But yeah, it seems very. Who's this for?
So if you're like a super small team and you got your data in Postgres or whatever, even if you have a derived data use case, you could still keep using Postgres for everything, right? You can think of it as like, well, I have primary tables and I have derived tables, and it's all inside Postgres, right? That's fine. At small scale, you can get anything to work. So one of the aspects of Venice is the scalability, and that will come, at some threshold. There is no fixed, team size or whatever when you must have it. It's very case by case. But besides scale, I think there are other aspects where it could be beneficial at all scales, right? So there's some ergonomic aspect, I think, to the way that you load data into the system. So if you happen to have data that is coming out of some batch processing or coming out of some stream processing, you could pump that data into your Postgres database, but you're probably going to need to do a lot of glue code to make that reliable, right? So you don't want to take your database down by DDoSing it from your grid, especially if it's also serving online traffic. Do you want a refresh of the data set to be viewed as only partially refreshed, and then maybe it fails in the middle, and then your table is sort of halfway the old version, halfway the new version? In some cases, it's fine; it doesn't matter. In some cases, maybe you care for that, right? So you can, while you can do everything on your own, at some point, I think you get to a situation where it might be easier to have a specialized system, right? That does kind of the swapping of the data set on your behalf, all orchestrated, and the orchestration of, let's say you have batch inputs and stream inputs, and you want to maybe layer the stream input on top of the batch. We're engineers, we can all build everything, and on our own, maybe we have a proclivity for that, but also it's nice if somebody else wrote it for you instead, right? So yeah, I think in terms of feature stores, nowadays a lot of people are using stuff like Redis, or maybe some other kind of key value store, and I think they're finding out that they need to write a lot of that glue, or that they're using someone else's glue, but it's not that reliable. So yeah, you can think of Venice essentially as a integration platform for this derived data, right? You pump data from a bunch of sources, it all gets integrated, and you can sort of host your views, your derived views or materialized views of the data in there.
The feature store angle is interesting too. So I mean, but you're talking about views, derived data, but also the capability of a feature store.
Yeah. So
yeah, that's interesting.
So Venice is sort of the storage part of the feature store, right? So and that is another field which is sort of very in flux. So it's sometimes hard to grapple with it, but the way that we've built it at LinkedIn is we have a project called Feather, which is also open source, which we used to call Feather our feature store. Now, some people in the industry are starting to tell us, no, Feather is much more than a feature store. Feather is a feature platform. I don't know if that term will stick or not, but essentially what you get with Feather is like kind of a catalog of all of your ML features and some kind of definition of how they were gotten, how they were massaged or generated in some way. And then Feather, our feature store or platform, has pluggable storage, right? So you can put the data that Feather generates into Venice or elsewhere. At LinkedIn, we have a variety of systems that Feather encapsulates, but Venice is the most popular one, right? So more than half of the ML features used by online applications through Feather are actually stored in Venice under the hood. So, so that's the way we do it at LinkedIn. In open source, these two projects are still kind of separate. We're hoping to release a bit more of the glue between them to make it easier to use them as a package at some point. But internally, they're pretty tightly integrated, and that's how we're doing the feature store stuff.
Yeah. When you talk about views, is there like an option to have different featurizations of the same data, for example, in different views?
Yeah, so there's a variety of design patterns for how people have achieved that. The way that we're sort of heading now, or advising that our internal users head now, is if they have kind of a significantly different version of how the feature is generated, let them have a separate Venice table for it. And nowadays, it's, at least internally, it's very easy to create Venice tables, right? We have them come and go like on a daily basis or weekly basis. We even people can do it self-service by clicking some portal, but they can even have scripts that dynamically generate whole new Venice tables automatically. So the whole productionization of a new ML feature sort of ties into that, where they sort of register it in the catalog, into Feather, and they also push it into Venice as a new table, and that gets kind of linked. And then when they go to query that feature, they know where to find it, thanks to Feather. So that's how we're doing versioning mostly nowadays. In some cases, people choose to have the multiple versions within the same table. That's feasible also if they wish. And there are pros and cons, more than one way to do things.
That's super cool. Davis, what's up, Davis? Says feature stores are dead. Long live feature platforms. I think he's joking, but yeah.
You heard it here first.
You heard it here first. Yeah, it might be true. Yeah, it's interesting. I think feature stores are kind of all the rage a couple years ago, with Feast and Tecton coming out with their feature stores. I think it was derived from Michelangelo over at Uber way back in the day. But yeah, curious to see where it all goes. Well, cool. I know we're coming up on time. Terrific conversation. I feel like we can keep nerding out on distributed systems for hours. This is definitely one of the more technical Monday morning data chats or Thursday morning data chats we've had in a while. So definitely appreciate hanging out with us. For people who want to learn more about you, Felix, how can they do that?
Well, I'm happy to connect on LinkedIn or Twitter. I share thoughts on these platforms. I also have a blog called philosopherping.com where I ramble about things. And as far as Venice is concerned, we have a Slack channel for the community. And so you can find all those resources at venicedb.org. So yeah. Reach out any way you'd like if interested.
Yeah, it's an awesome project. Yeah, I think you put it on my radar back in I think when it came out in September, or when you released it. Yeah, so like this looks cool. Get you on a show, and here we are. So awesome, good to have you. Speaking of shows, Monday Morning Data Chat next week we have Will and Cody from Coactive. So this is going to be a really good show. We're going to talk about unstructured data and the role of AI in unlocking the value of unstructured content. So Cody is one of the co-developers of MLPerf. So he's kind of an OG in the ML space. So this is going to be a really good chat. I'm going to be broadcasting from Paris. Are you going to be stateside, Matt, on Monday, or where are you going to be?
Let's see. I will be stateside. Yeah.
Okay,
so I'll
cool.
be broadcasting from here, from Brooklyn on Monday.
Okay,
yeah.
Cool. So I fly into Paris on Monday. Hopefully, I'm able to make it to the show on time. If not, it's just Matt. So yeah, and then Matt and I are actually this time next week we're going to be in Verbier, Switzerland, giving a talk there for skiers and data, put on by Chris Tab and Elite Data. So if you're in the area, come say hi. I don't know why you would be in Verbier at this time, but if you are, come give us a shout out. So yeah, Packed week.
It's
Awesome.
going to be busy. Yes.
Yeah, it's what it is. So cool. Felix, great having you on the show. I'd love to have you back on again. Really big fan of what you're doing. So thanks.
Great. Thanks for having me.
Thank you. And thanks to the audience.
Bye.
We'll see you next Monday. Bye.